But now we're interested in a deeper dive on the topic of land in conservation. We are joined by Mark Anderson from the Nature Conservancy, also a Kingsbury Browne Fellow. Chandni Navalkha, who is with the Sustainably Managed Land and Water Resources team at the Lincoln Institute, and Jim Levitt, with the same team and also head of the International Land Conservation Network. So we have some serious land conservation experts here to do a deeper dive in the work that we recognize that land can do in addressing the climate crisis. So Mark, I want to start with you. And by the way, we had Rob Kunzig from National Geographic, who was going to serve in this role, but he fell ill and wasn't able to join us. Mark, I'm going to start with you by asking about something that we've talked about a little bit, and I just continue to be amazed at. Some recent research or just your understanding of how powerful these ecosystems and natural areas actually are for being climate fighting machines. So tell us a little bit about how in some ways, right in front of us are these systems that just do incredible work.
Great. Can you hear me okay? Wow. And you're not a virtual background or anything? So
they haven't blurred their backgrounds. That's just us.
Enhance your appearance. So the science of carbon has, let me first say I'm an ecologist. I'm a director of science with the Nature Conservancy's Center for Resilient Science. And the science of carbon has changed incredibly in the last decade and even in the last 5 years. And I want to just give you a little peek at that because the implications for nature and carbon are huge. And I want to start with, I want to start actually going back to the 1600s. The first piece of science that was a breakthrough science, I think the average person on the street right now doesn't even get. And let me explain it to you. So there was an experiment done in the mid-1600s by this guy, John Bertram, and his son. And what they did was they took a pot of soil. They had good weight measurements. They took a pot of soil and they weighed it, and it weighed 200 pounds, right? This is such a great experiment. It should be done in every elementary school. Then they took a sapling of willow that weighed 5 pounds, a little sapling, and they put it in the pot. So they weighed the pot, they put the sapling in, they watered the pot for 5 years, and then they removed the willow. And they weighed the willow, and now it weighed 169 pounds. And then they weighed the pot, and the pot weighed the same. And they were like, where did the tree come from? Most people think trees grow up out of the ground, but they don't grow up out of the ground. There's nothing changed in the pot. So they wrongly concluded it must have been something in the water. We've been watering this, we must have been putting something in. And it took another 100 years for Joseph Priestley to figure out that the tree is materializing out of the air. It is literally taking invisible carbon molecules out of the air. They are absorbed in the leaf, they're split, so oxygen is released, which we breathe, and then the rest of it turns into carbohydrates and sugars, which is organic matter. It's the base of all organic matter. So when you see a tree, or even if you see a whole forest, that forest materialized out of the air. And the tree is growing down. The roots underground is all coming from the air. So that's the first piece of science. Now that was 1650. In the last 5 years, there's been a bunch of other breakthroughs. So you probably hear, if you talk to foresters or if you talk to conservationists, they talk a lot about the rate of growth of a tree. And they think the faster that the tree is growing, the more carbon it's sequestering. Have you heard this? That is not true. So what it turns out, they've tested this, and you think about that first experiment. The amount of carbon is really related to how many leaves are there, the area of the leaves. Leaves are like little solar collectors, you know, and so you get a tree that has like tons of leaves. That is like having a solar farm with tons of solar panels, and that's what's collecting all the carbon. So it doesn't have anything to do with tree growth. It has to do with the leaf area. So when you see an old forest or a big forest, that is tons of leaf area. Now, what's confused people is you see these old trees and old forests, they're not really growing that fast, and people are like, well, where is the carbon actually going? You know? And so just in 2017, this woman in her lab, Tamara Klein, they got a crane and they released labeled carbon dioxide really above a canopy of a forest so that they could trace the carbon to see where it was going, you know? Because if you ingest carbon, it's got to go somewhere. You know, our own growth rate stops at around 20, you know, but if we ingest carbon, it goes somewhere, you know? It's got to. What they found was, I mean, it made the journal Science. It came, you know, it kind of shook the. First of all, they found that most of the carbon was immediately being transferred underground. You know, so most of the carbon is going underground, and then up to 40% of the carbon was being shared with other trees. You know, so there's an underground. There is a network of roots. So you know, a tree. About 2/3 of a tree is underground, about 1/3 above ground. The network of roots form, and then there's mycorrhizal fungi, which form with almost every kind of plant, and it connects those roots together, and it allows carbon to be shared back and forth. So the forest is creating this huge underground carbon pool, you know, and the implications of that pool are huge because, first of all, it goes back and forth. You know, like if you're a conifer tree, you have little needles, and you might need more carbon in the summer, and the deciduous trees will transfer carbon to the conifers. And in the winter, it's the reverse. The deciduous trees lose their leaves, but the conifers are still photosynthesizing, and they can transfer carbon back. And if a tree gets injured, you know, they get transfer carbon to it. Or if a young sapling is getting established, they can transfer carbon. So it's this amazing carbon pool. So the implications are you've got a system. Well, I guess one more breakthrough, and then I'll stop. One more breakthrough is the way that the tree is actually adjusting to the light and carbon pool. So if you think about our eyes, here, you know, we actually have 4 kinds of photoreceptors in our eyes: red, green, blue, and light dark. And what I'm doing right now, I'm getting all that and I'm arranging it into an image in my head, and then I can react to that image. Well, plants, they now have found, have 11 kinds of photoreceptors. They can see all sorts of light that we can't see, and they have growth responses to every type of light. And that growth response is so they can maximize their carbon. You know, that's what they do. So we're living on this planet, you know, with these other organisms, these other forms of life that have developed for millions, almost billions of years, you know, in order to take carbon out of the atmosphere. That's what they do, you know. And it seems to me, and their whole life is tailored to removing carbon, using carbon, sharing carbon. And it seems to me like that's the most natural partner we have in our fight against climate change, is we should be working with trees, you know, and using their ability to do this, you know, to our own advantage, to the degree that we can. And every time we remove, it's the fastest, cheapest possible solution to removing carbon from the atmosphere. You know, we can come up with these highly technological things I won't go into, but you know, they're expensive and they're slow and the science is undeveloped, and here we are already living with these forests and grasslands and bogs, you know, and mangroves. All plants do this, that have developed their lifespan around extracting carbon. So I'll stop with that.
Well, that is a good reminder to, wow, that's that's a good reminder of just what a treasure and a powerful system it all is, and that much more worrying that the deforestation and land clearing is going on. Now, Chandni, I want to turn to you and the recently published report, which you have out in the back and also on the tables, to take a brief look at one set of strategies that has to do with conservancies and land trusts to sort of chip away at the acres that need to be protected. Can you tell us a little bit about that?
Yeah, absolutely. And Mark, you talked about trees being natural partners, so I'm going to talk about land trusts and conservancies as natural partners in addressing climate impacts and climate change around the world. So land trusts and conservancies are doing really important work providing solutions to climate change with multiple benefits, solutions that can range from finding the right places to site renewable energy to protect biodiversity, to managing stormwater, to maintaining biodiversity. And so this recently published Policy Focus report, which all of you should have in front of you, really aimed to bring these actions to the forefront and to share emerging ideas on how land trusts and conservation organizations can tackle some of these issues with practitioners and policymakers and decision makers really all around the world. And that's very much what we do in our work at the International Land Conservation Network, which is a project of the Lincoln Institute. We aim to leverage global expertise to advance private and civic land conservation around the world, precisely because we feel that these are organizations who are natural partners like trees, who have the ability to do this kind of work. And I should note to your question about tackling the numbers of acres to be protected, that it's not just about increasing the acreage protected, but about protecting the places that matter to people, to biodiversity, and to climate, and about ensuring that the decision-making that goes into conservation is equitable. So the initiatives that are highlighted in the report hopefully match those kind of goals that we have. And the way that we selected them was that we chose exemplary cases that are strategically significant, that are creative, that are measurably effective. So the measurability is extremely important in this field, transferable to other parts of the world and adaptable, and enduring so that they will last for the long term and will help future generations to inherit the same kind of planet or a better planet than we have. So one of my favorite examples from the report is that kind of illustrates all of those pieces is the Nature Conservancy's work on water funds in Latin America. Water funds bring together land and water management by linking upstream communities with downstream water users to cost effectively protect source water quality and supply through land conservation and stewardship. And it's just an incredible example because the concept began in the US, it spread to Ecuador with the Quito Water Fund, and then through the Latin American Water Funds Partnership, it spread all across Latin America and is now being implemented in Cape Town, South Africa, and in different parts of China and beyond. So it's just an example of how these ideas can have global traction and can have greater impact by spreading in this way around the globe. And in many cases, land conservation organizations are directly reducing emissions and increasing carbon sequestration. So one of the examples that we have in the report is from Greening Australia, which is working on a broad-scale restoration program on grasslands, native grasslands, and grassy woodlands in Australia, which, as you mentioned, are important carbon sinks. And then they're also addressing the land and competition issue that was a part of the discussion earlier in this forum by helping to tackle the issue of where the renewable energy infrastructure that will help us to meet the net zero targets is going to be sited in a way that can reconcile climate and biodiversity goals. And so the Nature Conservancy's Site Wind Right program really shows that you can have that massive wind energy development, infrastructure development, but still in a way that will respect and will have minimal impact on at-risk species. And I think the last point I want to make is that all scales matter, and Jim will talk a little bit more about this. But so far I've talked about relatively large-scale efforts with the Nature Conservancy and Greening Australia, but a tiny organization in Baltimore called NeighborSpace is using GIS mapping that was developed for really large landscapes, but kind of turning it on its head to identify little parcels of land in Baltimore that to conserve, and that will improve livability and resilience for communities that are facing urban climate impacts. So that's kind of the range of cases, and that's just a few of them that we touch on in the report. But I think the main message that we're trying to get across is that land trusts and conservancies offer a lot in terms of the resources, experience, and ability and nimbleness to address climate impacts, and that they're increasingly doing so in a way that's pushing forward partnership-based collaborative work that is occurring across sectors and across stakeholders to really provide multiple benefits that will tackle the number of different ways in which climate is going to impact society and our environment. So that's kind of an introduction to the report, and I think Jim will go a little bit deeper into the cases.
Yes, absolutely. Jim Levitt, you have a couple of case examples that we'd be delighted to hear about. This strikes me as yet another, is just shoulder to the wheel against some pretty tough circumstances, whether it's land clearing in the Amazon, or how do conservationists keep their chin up and really have an effect?
Great question. How many of you are familiar with Suzanne Simard's book, Searching for the Mother Tree? So I recommend it to everybody in this room. Some of the science is pretty dense, but the story she tells is amazing about how, as a young woman in British Columbia, she figured out how trees are not separate individuals, but this densely interconnected network. And not only do they feed carbon to one another, they feed things that help them protect from invasive pests. They signal to one another when something's going to happen that might hurt the forest. They are a super organism. And she figured this out as she was trying to regrow trees in an industrial forest in British Columbia, and really has changed the whole global paradigm about forestry. So it's kind of an obscure book, but I promise you, if you can Google her on television or read her book, you will really enjoy the story.
Read the overstory also.
Yeah, read the overstory.
And she is a model for a character in the overstory.
Yeah,
right?
she is.
Exactly.
Patricia.
Yeah, yeah. Lots of good stuff on this, brilliant female scientific pioneer who's really changed the way we think about these things. To build on the two analogies before me, land trusts and conservancies are very similar in relationship to the big sequoias that are national governments in a way that we talked about with these networks before. There is no way that national governments can tackle the conservation challenge by themselves. There's no way state governments or local governments can do it by themselves. We need all of the sectors involved. We need the public sector. We definitely need the private sector, the nonprofit or civic sector, the academic sector, and very important and only really becoming apparent right now, we very much need indigenous communities around the world to be empowered, as someone said before today, to help with this fight. So what we're going to focus on, and what this report focuses on, is the civic sector. We're not trying to pretend that we can do it all by ourselves, but we are an essential ingredient. Maybe we are the birch trees in the forest that has some very tall pines. Okay, so there is a wealth of information on the global presence and work of civic sector land conservation groups at this website, which is a website inside the Lincoln Institute family. And if you look at the resources section of the International Land Conservation Network's webpage, you're going to find hundreds of documents that describe experiments that are going on 6 continents around the world. And we're all sharing this information back and forth on an almost daily basis. Yeah, there we go. So I'm gonna describe 3 of the cases here, and I want you to notice the following: that these civic organizations that are operate at a variety of scales, from the neighborhood level to the continental scale. So they're all important components of this global system of conservationists, or this global community of practice, that they often offer with their projects a wide range of public benefits through nonprofit means. And there is almost always in their projects cross-sectoral collaboration. Land trusts don't do their work alone. They need funding from public sources and from philanthropists and from the sale of ecosystem services from lots of different places. And they need, increasingly in places like the Amazon that I know Anthony is very interested in, they need indigenous people to work alongside them to get the job done. This is a case in Baltimore County, outside of the city of Baltimore, with Baltimore Neighbor Space. They took an old Hess gas station that was leaking gasoline into the ground, remediated the soil, put a public park in, and under the public park, very importantly, they put a huge French drain that takes stormwater in the event of very severe stormwater events, which typically carry with them all of the oil and crud that's on the streets of Baltimore. What they have done as a result of that is stopped the flooding that occurs in houses in this low-income neighborhood from going into the basements of the residents, and it much better goes into the soil and is absorbed there. So a scope of benefits: recreation, green space creation, soil remediation, stormwater mitigation, and certainly cross-sectoral collaboration with the County of Baltimore that gives them developers fees with certain FAR regulations, as well as private developers who pay those open space fees and who take pride in the creation of these vest pocket parks throughout Baltimore County, which had virtually no open space 20 years ago. On a different scale, let me tell you about an organization called Para la Naturaleza. Chandni can say that in Spanish better than I, which is the working name for the Conservation Trust of Puerto Rico. The geography of this organization is island-wide, so much larger than a neighborhood in Baltimore. And the story of Para la Naturaleza is remarkable because they pivoted completely in the hurricane of 2018, I believe it was, when some of you remember a certain president of the United States kind of tossing paper towels out to the local residents, which did them no good. These guys mobilized communities all over Puerto Rico in I think a dozen community centers, and really they went directly to the assistance of these neighborhoods that were in dire emergency and helped them build their ways out of it by cleaning up, by bringing them supplies, by rebuilding houses, by completely putting aside for a little while their conservation mission to protect the people of Puerto Rico in the event of a climate change-induced natural disaster. They won the trust of these local communities in a way that's difficult to describe, and they have resulted in landscape scale restoration of Puerto Rico, restorative agriculture projects, and enhancing carbon sequestration, which is a mitigation effort. They also are helping to run schools in Puerto Rico that educate young children in environmental issues. Again, they got philanthropic funding. They had scores and scores and scores of community volunteers and almost no money from the federal government or the state government. Everybody was on their own. These guys just dug in and said, we've got to make a difference for our people right now, and they succeeded. And finally, I will talk to you about an initiative that's really now on a continental scale because the Nature Conservancy is expanding this project from coast to coast in the United States. It's called Sight Wind Right. It started at the chapter of the Nature Conservancy in Kansas, where the director of that chapter had the very clever idea of saying, let's not just say that we're opposed to the siting of wind turbines. Let's figure out those places where we don't think that wind turbines should go because of the presence of biodiversity conflicts, and identify those places where we can really expand rapidly on our renewable energy resources. So if you look at the maps that I've got up on this slide, the first map on the top is the wind resources of the wind belt in the United States. The deeper the red, the higher quality the wind resource. The second map to its right is the biodiversity layer, and it's showing all of the different places that there are biodiversity conflicts in that same region. It took 100 universities 2 years to compile this map, and they're constantly working at updating it and expanding it to, I think, 48 states now. They took the civil engineering layer, that's the third layer you see there, where there are airports and telecommunications facilities where you cannot put wind turbines. And they sort of silkscreen those one on top of the other. And the green spaces that you see on the bottom map are places that don't have a conflict, that are suitable for wind energy development. And they figured out at the capacity of wind turbines in 2018, which is lower than the per turbine capacity that we have today, they had a terawatt of capacity to generate electricity. That's about equivalent in raw capacity to the entire electric power infrastructure of the United States. So the argument that we don't have good places in the United States to put renewable energy resources is really not a good argument. What we don't have is enough intelligence to know where to put them so they're not in conflict with biodiversity, they don't cause seismic problems, they don't do a number of things. But this is not beyond the wit of humankind. We have the GIS resources, we have the intelligence in universities to do this, and this was all started by a guy in Topeka, Kansas, who said, gee, we gotta work on this. It took them and the rest of the Nature Conservancy 20 years to get this far. It's becoming continental in scale. It's including solar power now, and it is informing similar efforts in China and in India. So great oaks from little acorns do indeed grow.
Jim, you could leave that up. Could you just leave that up for
Sure.
a bit? We can come back to your concluding comments.
Go
but
ahead.
I want to jump in because this is, I mean, in some ways it's rather obvious, but I think it's so important, this idea of using technology to monitor land use and climate disasters, inundation, fires, drought. But just to have a kind of a dashboard on the planet, in the way that you've described here, perfect application. But Mark, can you just jump in and tell us a little bit about your Nature Conservancy work and the land resilience mapping tool, which is this terrific resource where you can find out how much carbon is stored, broadly speaking, in a given area, and how important it is to really be guided by that data that we get from satellites and other means.
Yeah. And I should have sent the link out, but I'll send you the link out. You can play with this tool yourself. You can look at your backyard. So conservation has also changed in that we now have access to, thousands and thousands of layers of comprehensive data sets that were not available even 8 years ago, And by analyzing these data sets, as Jim's, good example, we can start to have really effective solutions for how to sustain nature at the same time we're sustaining people. So I don't think I could have said that 10 years ago. We still may not have political will, but we at least have the science and to come up with a solution. So my team has been working on what we call climate resilience, which is thinking about how climate change is distributed across the landscape. So when you see climate models, I don't know what you picture in your head, but they're usually picturing sort of a flat, homogeneous landscape, like a piece of glass or something, and the climate is superimposed on the piece of glass. But that is not really how the Earth works. The Earth is full of complexities. It has topography, and water percolates and collects in certain areas. And it turns out that the effects of climate change are very varied across the landscape. And you can actually find places where species and communities are buffered from the effects of a changing climate because they have so much climate variability built into the landscape around them that they can actually just move around locally and find their climatic needs. So just picture if in spring, like right now, if you were walking in an area of recent snow, you'll often see snow on one side of the hill slope, and then on the other side it'll be dry and hot. You can get like 10 or 15 degrees temperature difference right there in the landscape. And this is the kind of complexity that actually builds into the landscape and creates resilience. So we've finished just this January, we finished mapping what we called the resilient areas, the most resilient areas for the entire country, finishing with Hawaii. And that map just looks at where are the places where we think we could have success with long-term conservation because the areas have those topographic and hydrologic characteristics that will buffer the inhabitants from climate change. It's a key it's a key idea in sort of how we keep the full suite of nature on this planet with us as we change. We've also looked at, if nature, here's the trick though, is if nature is thriving, which is what we want, thriving in ecology means reproducing. You're reproducing more offspring than you have parents. That's a stable population, you're reproducing yourself, and a thriving population, you're doing a little bit better. And once nature has a thriving population, then those youngsters, kids, have to disperse over the landscape. And thinking about how nature disperses is also a key new idea. You hear about connectivity, it's a key idea in how we conserve nature over time. And again, I think one of the really interesting breakthroughs is there's all sorts of spatial complexity to how nature disperses. It's not like everything just goes everywhere at once. In fact, there's patterns that are very much like water moving through a watershed. You get overland flow that's spread out, and then you get main channels where all the water collects, and if you start to study those patterns, you can see where key areas are for conservation, where most of nature will be moving through relatively small areas. And things like the Appalachian Mountains is a great example of what we call a climate corridor, where much of nature will end up going through relatively small areas. So we've been trying to link, I'll stop here, we've been trying to link the resilient sites with all the topographic microclimates to the areas of climate connectivity that allow things to move across gradients. And this kind of solution, offers huge potential for expanding, on this kind of planning, so we can really think about a dynamic natural world that's moving and changing, and a dynamic human world where we're thriving and coming to meetings like this.
Okay, two things to build on what you're saying. And the first thing is, it's such an honor for us at the Lincoln Institute to have Mark as the Kingsbury Browne Fellow this year, because this guy is one of the world leaders in this climate science. He's really remarkable. And you can ask people anywhere in the world and they'll tell you the same thing. Mark Anderson is the man. So thank you for that. The second thing I wanted to point out is that the great irony of all of this is it is so true that all these GIS systems help us get insight into where we can best conserve land. And we're also coming to understand that the best world champion people to conserve natural systems are indigenous people around the world. So if you ask, as Anthony has asked before, how do we get our arms around protecting the fragmentation of the Amazon? One of the important answers to that, not the only important answer, but one of the important answers to that is give the indigenous people legal enforceable title to that land so that they are not defenseless against squatters who come down and steal timber and kill biodiversity. So these are people who are often, not always of course, but often operating at very low levels of technological enablement, if that's a proper way to say it. Yet they have an incredible ability to keep these systems, these giant trees that you're talking about, thriving and alive for centuries and centuries. And we really globally need to recognize that immediately.
Let's take it out to the group at large if there are questions and continue the discussion.